Here we will see a question from the chapter Mathematical Induction. Here question is, prove by the principle of mathematical induction for all n belonging to the set of natural number, capital N. Here statement is 4 to the power n plus 15n minus 1 is divisible by 9. Okay, question is very interesting. Let us see the solution here. What is given here? This mathematical statement is given, and mathematical statement is denoted by the notation Pn. So here Pn is 4 to the power n plus 15n minus 1. This is divisible by 9. We have to prove it. Okay, let us call it relation number 1. So first step, here in first step we have to show that P1 is true. How we will get P1? By putting n is equal to 1 here. So putting n is equal to 1 in relation number 1. So we will get here P1 is equal to 4 to the power 1 plus 15 into 1 minus 1 is divisible by 9. So here P1 is how much? This is 4 plus 15, 19 minus 1, 18. So 18 is divisible by 9, which is true. Which is true. 9 to the 18. So therefore we are getting P1 is true. So this is the first step. And second step, as per the principle of mathematical induction, second step we have to assume that PR is true. So second step, assuming that PR is true. So let us putting n is equal to r in relation number 1. So we will get here PR is 4 to the power r plus 15r minus 1 is divisible by 9. Correct? We are assuming it. So therefore if this is divisible by 9, means 9 will be factor here. So therefore 4 to the power r plus 15r minus 1, let us write it 9 into k. K is any positive integer. Since divisible by 9, so definitely 9 is a factor here. Let us write relation number 2. And third and last step, here we have to show that PR plus 1 is true. So here putting n is equal to r plus 1 in relation number 1, we will get PR plus 1 is here putting n is equal to r plus 1. So 4 to the power r plus 1 plus 15 into r plus 1 minus 1. We have to show that this is divisible by 9. Correct? So here we have to show that 9 is a factor of this expression here. So therefore 4 to the power r plus 1 plus 15 into r plus 1 minus 1. This can be written as 4 into 4 to the power r plus 15r plus 15 minus 1. Correct? And this is equal to 4 into 4 to the power r plus 15r plus 14. 15 minus 1 is 14. Correct? See relation number 2. In relation number 2, we are having the expression 4r plus 15r minus 1. Here we are having 4 into 4r. So we'll try to take 4 common here. So 4, and here we'll write 4 to the power r plus 15r minus 1. But we are having 15r and we are writing 4 into 15r to write in this format. So 15 into 4, 60. So we have to subtract 45r. So minus 45r. Okay. And we are having 14, but we are writing here minus 4. So we'll write here plus 18. So that 18 minus 4 becomes 14 here. Correct? And by relation number 2, 4 to the power r plus 15r minus 1 is equal to 9k. So this is 4 into 9k minus, from 45r plus 18 we can take 9 common. So minus 9, 9 5 ja 45 r minus 2, and this is equal to, you see here 9 is here also, so we can take 9 common from both the terms. So if you take 9 common, here we are getting 4k minus 5r plus 2, correct? So you see in this expression we are showing that 9 is a factor. What does it mean? It means that this is divisible by 9. So therefore it is divisible by 9. So we are showing here that this expression in PR plus 1, this expression is divisible by 9 because 9 is a factor. So therefore we are coming to the conclusion that PR plus 1 is true. So by the principle of mathematical induction, just we have to write one statement here. Therefore by the principle of mathematical induction, therefore by the principle of mathematical induction, this Pn, given statement Pn is true for all n. This is true for all n. So we are getting the result here. It has been proved. Very interesting question. So hope you have understood it very well. So we have to finish, we have to do this question in only 3 steps. Step number 1, to show that P1 is true. Step number 2, we have to assume that PR is true. And step number 3, we have to show that PR plus 1 is true. After doing all these 3 steps, we write this statement that by the principle of mathematical induction, Pn is true for all n. That's all about this solution. So very interesting, okay? So please keep in touch with these videos and enjoy learning mathematics. And we have to do so many questions in videos to come. Thank you very much.